The Quantum Zeno Effect. Imagine a boiling pot of water. What if simply watching it could actually stop it from changing? At the subatomic level, that appears to be surprisingly close to reality. In the quantum world, an unmonitored particle cluster of circles will naturally shift its shape and decay over time. But if you measure its state rapidly enough, this changing system appears to remain locked in its initial shape, unable to change. It is as if a watchful eye is freezing the system, but the reality is much more subtle. This phenomenon occurs because frequent quantum measurements or physical interactions with an external measuring device actively interrupt the natural continuous evolution of the particle's quantum state. Normally, a particle's wave function spreads out gradually over time like a widening wave, but each measurement collapses that wave, forcing the particle's timeline back to zero. This constant reset behaves exactly like a clock that only ticks when no one is checking the time, keeping the hands permanently frozen in a state of suspended animation. Perhaps the universe only moves forward when we stop looking. The Planck limit. Picture a smooth, continuous line. Imagine zooming in closer and closer, only to discover that reality itself is built on individual blocky pixels. In quantum physics, that appears to be exactly how our space is structured. If we visualize a smooth curved line, it represents our everyday experience of a continuous universe. But if we place a magnifying glass over this line, the smooth curve appears to turn into a jagged, stair-stepped grid. This boundary is the Planck length, indicating there is a fundamental limit to how small things can get. The equations indicate that space is indeed divided into these tiny, indivisible steps. No empty space can exist between these steps because space itself cannot be smaller than this minimum threshold. From this perspective, motion is not a smooth, continuous glide. It behaves like a series of rapid teleportations, where a particle jumps from one grid coordinate to the next without ever passing through the space between, flashing in and out of existence. This raises the fascinating possibility that our universe is built on a finite mathematical resolution. If we are indeed traversing a cosmic grid, then reality is not a smooth flow, but a highly organized calculation. Could it be that the fabric of space is simply a grid of cosmic pixels? Vacuum birefringence. Absolute empty space looks like a complete barren void, but quantum mechanics indicates that empty space is actually packed with virtual particles that constantly pop in and out of existence. To visualize this, picture an empty box containing tiny, simple dots briefly flashing on and off inside the void. Under normal conditions, these ghost particles are disorganized and chaotic, but in the presence of extreme magnetic fields, these virtual particles are forced to align, forming a rigid parallel grid like a crystal fence. This alignment completely polarizes the empty space, making it behave like a physical material. When a beam of light enters this polarized vacuum, the microscopic grid of aligned particles acts like a prism, forcing the light to split into two separate paths. If a single straight line enters the box, it hits this grid and splits into two separate lines inside the box. The results look as though the void itself has a physical texture, bending the path of light through its invisible structure. Even the most perfect vacuum contains a boiling sea of hidden activity, proving that nothingness is never truly empty. If empty space can bend light, true nothingness may not exist at all. False vacuum decay. Imagine a physical ball resting in a shallow valley next to a much deeper drop. In quantum physics, space itself may behave exactly like this ball, resting in a temporary, unstable state called a false vacuum. The physical universe seems permanent, but the timeline suggests we are merely resting in that shallow dip. If a single quantum event causes a tiny region of space to slip over the edge, the ball falls into the true lowest energy state. This sudden drop releases a massive wave of stored energy, creating a tiny bubble of true vacuum at that exact spot. This release of energy pushes neighboring space over the edge, triggering an unstoppable domino-like chain reaction. This bubble of true vacuum would then expand outward in all directions at the speed of light, permanently altering the laws of physics and also altering the physics that make up our bodies. Because this bubble moves at the absolute limit of speed, it is completely invisible, leaving no warning and no way to observe it coming. It almost looks as though our entire universe is a delicate tower of blocks waiting for a single subatomic piece to fall, leading many people to wonder whether our physical world is far more fragile than we assume. The bubble of absolute destruction could already be heading toward us at the speed of light. The fourth dimension. At first glance, the concept of a higher spatial dimension seems completely impossible to visualize. To understand how it works, imagine a flat two-dimensional universe inhabited by a flat square. If a three-dimensional cube were to pass directly through this flat world, the two-dimensional observer would never see the cube itself. Instead, they would experience only a series of flat slices that appear to warp, expand, and then shrink into nothing. By analyzing how shadows work, we can take this concept further. When you shine a light on a three-dimensional cube, it projects a flat, two-dimensional shadow on the wall. The shadow is a real physical shape, but it has lost a dimension. By extension, some interpretations suggest that our entire three-dimensional world is not the true structure of reality. If a four-dimensional tesseract were to pass through our three-dimensional space, we would experience only a three-dimensional shadow. It almost appears as though a solid shape is turning itself completely inside out, changing its physical boundaries without any logical explanation. This has led many people to wonder whether our entire physical universe and even our own bodies are merely thin slices of a much larger, higher dimensional reality. We may simply be three-dimensional shadows cast by a world we cannot see. Cosmic strings. During the raw, energetic birth of the universe, some theories suggest that the very fabric of space cracked as it cooled. This would create cosmic strings, hypothetical, one one-dimensional defects stretching across the cosmos. To visualize a cosmic string, picture a line that is infinitely long, thinner than an atomic nucleus, but so incredibly dense that a single mile of it would weigh more than the Earth. Because they warp the geometry of space itself, they behave like massive gravitational lenses. If a beam of light from a distant star travels toward a cosmic string, the bent space forces the light to split, traveling around both sides of the string simultaneously. This has led many people to wonder whether what we see in our telescopes is actually real. An observer on the other side would see two identical perfect copies of the exact same star, separated by empty space. It appears as though the universe is projecting duplicate realities simply because space itself has been torn. If we were to travel near one, the extreme gravitational forces might even create local time loops, permanently trapping us in history. Does a tear in space-time mean we can never trust what we see in the night sky? Strange matter. Deep inside collapsing stars, a strange state of matter may exist where normal atomic structures completely dissolve. Normal matter is made of protons and neutrons, but under extreme pressure, they may transform into highly organized strange quarks. This hypothetical substance is so perfectly stable that it is considered the ultimate indestructible form of matter. This extreme stability is highly infectious, because normal matter is less stable. Making physical contact with a single particle of strange matter, called a strangelet, triggers an instant collapse. The normal atom immediately reorganizes its internal structure to match the strangelet's perfect lower energy state. If we draw this, we show a normal atom made of loose circles instantly snapping into a rigid, tight grid upon contact. This release of atomic energy then pushes the neighboring atoms to collapse as well, triggering an unstoppable cascading chain reaction. It appears as though a strangelet is a highly contagious physical virus, reshaping the elements of our world into a heavy, uniform solid. This has led some researchers to suggest that massive patches of space have already been converted and are quietly traveling toward us. If you touch it, you are instantly rearranged. A single contact would slowly turn our entire planet into a cold, silent sphere of stone. White holes. If a black hole is a region of space where gravity is so intense that everything is pulled inside, its mathematical opposite must also exist. This theoretical object is a white hole, a cosmic anomaly where matter and light are violently ejected outward, making it completely impossible for any physical object to ever enter its boundary from the outside. It appears as though a white hole is a black hole running in reverse, spewing the history of an entire universe out into the void. Some researchers have proposed that when matter is crushed into the singularity at the center of a black hole, it actually tunnels through a wormhole. This tunnel acts like a cosmic pipe, releasing everything the black hole consumed out of a white hole on the other side. If we draw a black hole as a dark circle pulling a block inward, we can show it traveling through a tunnel and spraying out of a bright white circle. This means that a black hole is a massive drain pulling space downward, while a white hole is the fountain on the other side, pouring new matter and light into reality. Space-time equations suggest these two objects are permanently linked. The Big Bang itself may have been the fountainhead of a white hole, spilling us into existence. Boltzmann Brains. Imagine a neatly ordered stack of blocks that naturally collapses into a chaotic pile over time. This represents how energy behaves in our universe, slowly spreading out into random disorder. Yet, some researchers have proposed that over an infinite timeline, random particles floating in the vacuum of space can occasionally organize themselves back into complex structures by pure statistical chance. The vacuum of space is actually a boiling sea of tiny random dots popping in and out of existence. While it is highly unlikely for these dots to align into a complex object in a short time, infinity changes the mathematics. The calculations suggest that it is vastly more likely for a single conscious brain containing fake memories of a human life to spontaneously materialize in the dark void than it is for an entire structured universe to slowly evolve over billions of years. Your family, your home, your job, and all of your personal memories could have been generated in a single instant by a temporary random alignment of space particles. It almost appears as though your entire life is an illusion created by a floating cluster of atoms. Are you really watching this right now? Or are you just a lonely brain floating in the void? The many worlds interpretation. When we make a decision, we assume we are choosing a single path, leaving the other option behind. But some interpretations of physics suggest that the universe does not choose one over the other. Instead, it appears to branch into multiple parallel realities with each possible outcome playing out in its own separate universe. If we map a straight timeline, it does not remain a single line. Instead, it splits into two, and those lines split again, forming a tree structure. Every decision, every atomic decay, and every random event splits reality into an infinite, ever-growing tree of timelines. When you make a choice, the universe simply duplicates the timeline, creating a parallel version of yourself to live out the other option. This has led many people to wonder whether there is an alternate version of you currently experiencing every path you did not take. These parallel branches never interact, existing alongside us in complete isolation, forever out of reach. If we were to map this, the timeline would be overwhelmed by thousands of diverging white lines. We may never know which branch of reality is actually the original one.